To say that this one's been a bit of a challenge would be an understatement. Moment of truth. If it goes pop, we are having another bad day. So, welcome back. I say welcome back because it's been about 2 weeks for us since we've done any serious work on this plane. We've been doing bits because there's been bits to do, but we had a issue, as you may have seen previously, with one of the instruments. It means we had to send it back. Unfortunately, there was lots of to and froing between us and the supplier to try and find the fault with the problem. Anyway, we've had a delivery. To try not to risk too much, I've connected up the Daqu. I've done a separate CAN bus, so we're running 2 CAN buses on this, so we could separate in the Indus from the flight displays, so that are varying reasons. But anyway, we've done that. I haven't connected the Emsis up yet. It's easy for me to say. I just wanted to make sure that that Daqu is working properly and we're receiving it on the Nesis. So, moment of truth, if it goes pop, we are having another bad day. So far so good. Now this is promising because I'd already updated the software, and straight away from power up it's updating the firmware on the Daqu and loading it in and programming it, so that's better than I've had before. I'm quite happy. Right. Yes, we promised to not do anything daft. Alright, it's restarting. This is all good. I'll come back to you in a minute. So, there it is. Daqu on the CAN bus. That's very reassuring. I can go into the engine sensors and I need to assign these if they've not already been assigned to varying channels, but what I'm keen to do is get that Emsis back in. We'll see how that goes. So purely as a test, what I'm going to do is wire this directly into the CAN bus. There is separate power from this. I believe that you can run this directly off the CAN bus, which will make me feel better because I'm not in no rush to connect this straight to mains after the issues we had last time. So here goes. Win. That's very reassuring.
Now the main unit itself, this Nesis unit here, which is nice, I like it, I'm using it now, got all the nice ticker tapes on there, is loaded with options. You can pretty much set and pretty much program it to do most of the things. You can run full autopilot off this and everything. It's genuinely a very impressive machine. And but it was an X-display one, which means it was filled with with programming. It got lots of information already set in there, which wasn't relevant to this aircraft. So to say that I spent the best part of 3, 4, probably 5 days programming this unit wouldn't be a lie, because you go so far and it's like, well, what's that do? How's that? What's this for? And then you're sitting up all night reading the manuals that relates to another manual, and this has got to happen with this, and then, oh, have you got the right software and firmware updates? Right, that's how you do this. It just... It went, let's just say it went on. There was lots of doing.
So what I'm doing now is just programming the engine sensors. Everything is all plugged in, but because this was an X-display unit and I think that's been pre-programmed, what we got on the Daqu needs to relate to what's on these systems. So I have taken a picture of the Daqu. There's the wiring for the Daqu, and what I'm going to try and do now is relate this to that, and I'm hoping with that being a slave the two will talk to each other and I won't have to reprogram that, but we'll wait and see how it works out. But everything's going okay, which is great. Finally finished. To say that this one's been a bit of a challenge would be an understatement. It's definitely thrown a lot of curveballs, most of which weren't necessarily my fault. So for those of you who are looking at buying a Kanardia system, got it right this time, it's very important that you spec the right instruments to work with the right instruments. Mixing slaves and masters and flat screens can be quite a challenge. The issue being is that everything works on a CAN bus, so that instrument works with that instrument that works with that instrument, and that's okay so long as you've got one primary source of information. But when you've got different ones that need different sources of information, that's where it becomes difficult. Anyway, this system we've finally been able to get around so that we've got primary instruments working with the secondary instruments, and so should there be an issue in flight and the primary instruments turn off, that you still get accurate readings from the secondary instruments. So that's probably the easiest way that I can explain what we've done. But take a look at this fantastic install. So welcome to the basic setup. Excuse me for flying side saddle, it's just easier. So the way I've set this up is that we have a number of ways of powering it up. The iPad holder through a lot of issues in that it looks nice and neat, but actually on the back of it it's massive, so it meant that we threw all of the main switches into a different place. I actually quite like them there. They're out the way, they're easy to reach, they're easy to see. So what I did is I run the backup instruments to turn on and run with the master switch. So this will go, I'll just power up all the Indu instruments there, so backup airspeed, backup altimeter, backup VSI and backup RPM. So that's all there, that's all working. And then separately we have the EFIS switch, which powers up the Nesis, the primary flight display. Hopefully this will go through its startup sequence and won't throw me too many issues. There we go, here the screen coming in. What I did on this was I also, you see it flashing away there, is set up a backup. So this is there, all the settings that we've done are saved onto that USB stick, so it's, if there should be an issue you could just plug it straight back in, recall all of your old settings. So again, little things. So one of the main issues that we had was dual altimeters, and again I'm aware where you can use dual altimeters, but we don't do that kind of flying, and so there was a whole threat and error management there where we needed to resolve where you could potentially have two altimeters reading completely different settings. I couldn't let that leave, so how I've set this up is that you can alter the altitude over here on this instrument, and as that changes it also affects the altimeter on the other instrument, and vice versa. You can go into the pressure on this particular unit and you can recalibrate that, and that will automatically update the other altimeter, and so it's all working on the CAN bus. That sounds so simple, hardest thing I've ever done in my life. Right, okay, so this is where it gets then even more complicated, because we've added in a flap indicator system there, so you can see that it's showing the flaps as well, so you get movement and travel of the flaps. So stage 2, stage 1, and all of these are programmable, so I can move the 1s and 2s around to be exactly where they want. And then it can come into the options, and this is where I have spent the majority of my life recently. This is your basic user interface, but when you're going into the, that's a generic password by the way, so I don't mind giving it. When you're going into the actual setup of the system, you've got everything that's here, so this is where you can go into the settings of varying flap, trim, all the potential outcomes that you could possibly have. There, layouts, parameters, so each one of these you can go into, and I've had to go into in order to set the correct parameters. So this will then display either white, green, red, orange, whatever, for any instrument. That's all on there. Again, you can go into the, you got to program the Daqu, which is a little box over there with every one of the outputs to say what it is, and then the right sensor, and you see here there's a lot more options that we can use in the future. But oil pressure is on there, flat positioning system is in there, water temperature, oil temperature, you know, it's infinite. But each one of these you've got to go into and set in varying bits of information. So I have spent lots and lots of time getting used to how this thing works. But yes, not the easiest thing that I've ever done. I've spent many an evening diving into these manuals, and anyone who spent a lot of time reading manuals, I'm sure you'll appreciate it, that they're not necessarily in the order that you need them to be, which is irritating, because I'll remember this to get this job done and then somehow it'll disappear and I'll have to re-remember it next time we do another one of these. But what a fantastic unit. These Kanardia instruments are fantastic, and having spent the last couple of weeks ping-ponging emails backwards and forwards with them, I can also say what a fantastic company in terms of after sales. So yeah, thanks.
The flight test of this was quite intense, pretty much what we would do on an initial flight test. So we did a full airspeed calibration. I mean, they're good fun and everything, trying to fly in thermic conditions and being at weight, yeah, lots going on. But it threw up a number of problems. Again, not for 1 minute would I consider myself to be an expert in anything, but I've flown enough, let's say, to know what one should feel like. And this wasn't right.
I hate it when stuff just doesn't work. Yeah.
So, welcome back. Not that you went anywhere. Completed the check flight on this plane yesterday. Hopefully was trying to do the permit to fly check flight so we could get it permitted and back out the door. Also a great way of testing the instruments, and I was dubious because I'm not a huge fan of flat screens and all PFDs and all of that. But I've got to say that Kanadia Nesis was a fantastic unit. Very easy to read, very easy to switch between the screens that I wanted to look at. and all of the additional backup instruments all work great as well. So it was great to do that. But what I did notice, and this is something that's obviously nothing that we've been working on, was a number of things on the check flight, one of which was the standard a lot of heavy right foot on the rudder. Normally it's to do with the rudder bungee either being past its newness or has been offset for some reason, but I just found that I was using a lot of right rudder just in the cruise, which is where I like to be fully hands-off trim. But the other thing that I noticed was a number of things. One, the climb rate was ridiculous, as in it went up real quick. And the other thing that I noticed in the cruise, or going through to full power, that the full power was over 5,200 and something. And that's not normal. It should be more like 4.8, maybe 5,000. So that's leading me to believe. Oh, I also noticed that for a similar RPM that I always sort of fly at to get a benchmark, that the airspeed in the cruise was low. So I've got a really good climb rate, or a better than I would expect climb rate, slow cruise speed, and a high full power, which leads me to believe that the prop here has been set to the wrong pitch. So I'm going to do some investigation and I'll report back to you. Okay, so I think I found the problem, quite a dramatic one. And this is something that I read about and get asked about quite a lot, in that people read that their Rotax can go up to 5,800 RPM, and mine's only doing 5,000. Unfortunately, it's where people are reading two different manuals. Yes, you've got the engine manual, which is saying it can't, max RPM is 5,800, that's fine, but the moment you stick a prop on it, then it's different. Now you're down to the airframe, and this is where the BMAA have a fantastic website. So what I've done is I've gone on to the BMAA's website, I've downloaded the HADS information, Home Amateur Built Aircraft, technical sheet for this particular aircraft, and the Skyrangers are brilliant because they give you every bit of information you need. I'll bring this onto the screen so you can see it, and it should be a 283 1800 3-blade propeller. It is that. I've checked the serial number and I've measured the prop, and it says for a 180 that it should be 35 degrees at 33.5 centimeters. So 33.5 centimeters down the hub, it should be at 35 degrees. Fortunately, again, because our friends at Flylight are amazing, they have a pitch setting tool, and so that black line there, I don't know if you can see that there, that black line there is where it should be. So that should be the angle of each of the blades, whereas this one is down there. So you can see there is quite a significant change in pitch on the propeller. Now that will give them a much better climb rate, yes, but a reduction in cruise speed. The bit is that this aircraft is only certified on its permit to fly with the propeller set to that pitch. So anything outside of that, it's a permit fail. This is why you should be checking the pitch of your propeller regularly.
And now you're in that black hole, because it could be a 10-minute fix, it could be a 10-hour fix. I'm too nice. Do you charge for that? Well, no, not really. I should charge for that. Anyway, I just like our customers to have planes that fly really, really well. You don't want to come and have the kind of work that our customers have and then be massively disappointed with the way it flies. Not that we turn old planes, well, we do kind of turn old planes into new planes, but I really got to know the guy who owns this plane, as I get to know all of my customers, and I just wanted him to have a nice plane. See, this is why I like backup instruments, because I just pressed a simple button and the unit decided to have a rethink by shutting down and restarting again. Now 5 seconds, when you're in the rough stuff, can feel a very long time. And you sit there staring at it going, are you going to turn back on again or not? having had a number of recent engine failures and land outs, all unpre-planned. Already worked out where I'm going for when this thing turns off, when I'm right over the middle of the water. Beverly traffic, this is Golf, Delta, Oscar, Zulu, Zulu, approaching from the south for a standard overhead join for runway 12, Beverly traffic.
Golf Zulu, Zulu, we're using a runway 12, which is a left-hand circuit, QFE 1016, got no other reported traffic at this time, sir.
Roger Beverly, runway 12 left hand in use, Q and H, QFE 1016. Golf Zulu Zulu, downwind runway 12 left hand. Golf Zulu Zulu, far to land on runway 12.
Zulu, Zulu, if you want to just turn left slightly, it's going to go through the gate on your left-hand side there, just behind that aircraft. You'll have to stop just short of it.
Roger. Am I right in the way, Ian?
Oh no, you're fine there, my friend. You can drag it through the gate when this aircraft moves.
Well, we made it.